Hello everyone. So it's a continuation of the transfer function. I'm just directly moving to that slide where we stopped in the previous video. Yeah, mechanical dynamics. So in the mechanical dynamics also we completed that one, right? So now I'm taking the transfer function with respect to speed to voltage. Okay, I'm not taking any other perspective. Because it is having right now we are having two type of voltages will be there. So that's why I'm just taking it a consideration like speed to voltage. Now substituting the mechanical equation where we will take the substituting of the mechanical equation and we solve that one, then automatically what will happen is we'll get the equation with respect to this one. This is not omega, sorry, it's not ohm thing, it is a inverse relation of that one. So that will come here, and finally this equation will be in this way. If you see here, this is the second order system, right? Just remember that one, this is a second order system, and the what are the things will be there here. Whatever it is a second order transfer function related to the motor speed to q axis voltage, because we are considering the here it is a only the q axis voltage, not d axis voltage. I'm not considering, I'm considering only the q axis voltage. So that's why I need to consider that one itself. So the next one is transfer function towards position to voltage. Before I is considered with respect to speed to voltage. Now I am considering position to voltage, because the voltage how it is impacting on the speed, the voltage how it is impacting on the which position. That means either it will be a clockwise position or anti-clockwise position, or which degree it is rotating, how much degree it is rotating, what is the error correction. That is everything we need to understand. That because of that thing, we need to take the position also into consideration. So that's why I'm taking a consideration of the transfer function with respect to position. When I'm to get the position control, what I need to do is I just simply divide it with the s, then automatically it will become the position based system. Then if you divide that one, what is happening is the second order system will be converted into the third order system. Whenever the third order system will be increased, this third order includes both electrical and mechanical. If you see, each and every term will having the both electrical quantities will be there and also mechanical quantities also is there. So this is how the system is converting the having a transfer function of both the electrical and mechanical quantities, both is included there. So here J and B control the speed and damping, and while L and R will be the shape dynamics of the system. Okay, the numerator represents the motor torque control, and the denominator represents the whatever the Q axis voltage control will be there. So this can be happen to that one. And the next one is to reduce the third order system to the second order system. What we are doing is we neglect the electrical time constant. That means electrical time constant will be neglected. Then automatically the electrical dynamics are much faster than the mechanical ones, because it is time to time very frequency 20 milliseconds, it will varies very fastly compared to the mechanical one. We can neglect the inductance. Okay, whatever the inductance is, that an inductance can be neglected. That means this term whatever it will be, that term completely, and this term also will be neglected. Then automatically what will happen, jr into s square plus br into s, only the remaining part. So the here if you see, this terminology is under the second order system. So then this is the final transfer function of a AC servo motor. So here with respect to this one, we need to control either it need to be a PI control or PID control, or a lead lag compensator, whatever it will be, we can use to this equation is used to help the real time controlling of the motor position or speed or water with respect to voltage. Okay, now we need to see the application areas also, because ultimately where we are, as it is in the DC servo motors, so we are using the CNC machines, medical equipments, aerospace, robotics, engineering. In the same way, here also we need to see where we are using this one. So the AC servo motors are able to use in high speed CNC machine, not in the low speed CNC machine. In the low speed CNC machines, they are using the DC servo motors. When it is high speed, when it related to, then they are using the AC servo motors. In the robotic arms also the same, and also aircraft actuators. But before itself in the air, so aerospace means like it is a drones or everything which is having very not having very much of high speed, so that's why they can be used in the DC servo motor. But when it relates to the aircraft, it have a very high speed which is need to be in a very high altitude. So that's why they are using that one. And 3D printers which have more precision and everything. Every printing need to be very detailed, so that's why it also takes that one. So these are the application areas. The same little bit of nearby things will be there when it relates to the DC servo motor and AC servo motor. Thank you.